Okay, so we're going to talk about the last of the variables when it comes to thermodynamics, which is Gibbs free energy. Gibbs free energy is delta G. So what free energy is talking about if a reaction is spontaneous or not. So if delta G is a negative number, that means the reaction is spontaneous. And what spontaneous means is that this reaction will proceed without any input of energy. It's spontaneous. It will happen by itself. If delta G is a positive number, that means this reaction is not spontaneous, which means the reaction will not proceed without any input of energy. So the energy diagram for this would look like if you had free energy versus the progress of a reaction. So we'll say this axis here would be free energy, delta G, and this would be the progress of the reaction. So we'll say here are the reactants, and here are the products. So if this is a spontaneous reaction, then that means the energy of the reactants is up here and the energy of the products is down here. This is a spontaneous reaction. It's an N. And the delta G here would be a negative number. It would be whatever this value is here, a smaller number, minus this, whatever this number is here, a bigger number, it would give you a negative number. If delta G is negative, then this is a spontaneous reaction. Conversely, if we do the same thing, free energy, and then the same thing, the progress of the reaction, reactants, products. A non-spontaneous reaction would look something like this, where here's the energy of the reactants, here's the energy of the products, whatever this number is up here, a bigger number, minus this, a smaller number, delta G is going to be positive. This is going to be a non-spontaneous reaction. So this is going to tell us if a reaction is spontaneous or not. Is it going to happen on its own or not? So before we get too much into delta G, let's take a second and wrap up everything we know about these three different variables that we're talking about with thermodynamics. So we have enthalpy, which is delta H. Delta H can be positive, which means it's endothermic. Delta H can be negative, which means it's exothermic. And this has to do with heat of chemical reactions. Then we can have entropy. Entropy is delta S. If delta S is positive, this means more disorder. If delta S is negative, this means less disorder. And delta S has to do with energy dispersal. And now the last thing that we just talked about is free energy, delta G. If delta G is positive, this is non-spontaneous. If delta G is negative, this is spontaneous. And this has to do with, will a reaction happen on its own or not? So we could also say this reaction, is it favorable or not? Or it really just has to do with spontaneity or favorability. Will this reaction happen on its own? So these are the three variables that we're talking about in thermodynamics. We talked about enthalpy in chapter 9, heats of reactions. We talked about entropy in the beginning of chapter 12. Is a reaction increasing or decreasing disorder? Now we're going to put enthalpy and entropy together to talk about free energy, which talks about, is this reaction energetically favorable or not? You might hear that term, energetically favorable. Will it happen on its own if it's negative, or not happen on its own and you would have to put in energy? So these are the main topics that now we're going to put all together when talking about free energy.